Hello, it's Miss Nakayama again with 9.1a, Simplifying and Multiplying Radicals, but part 2. Okay, so you want to turn around to the second page of your note sheet, go to section 4, and we're going to do more of the product property, which we kind of have already been doing. I mentioned to y'all that earlier in the first part, okay? But we're concentrating on a little bit more difficult problems. All you did in the first one was simplify them, but now we have actually multiplying square roots together. So before we do that, I want to refresh you again so we have these handy. Your perfect squares, remember we talked about finding what those numbers are. So I've got 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared. Wrote it right correctly this time. 13, 14, and 15 was enough to get us started. So I'm going to tell you, you're probably going to instantly want to multiply these together because that's what that says. But I think it saves you some work and helps you understand the process that we're going to go to after this, which involves variables, if you don't multiply these numbers. So get used to factoring, because what you're going to have to do, what we did in that first lesson, y'all, we had a number and we had to factor it. Okay, so now you want to take two numbers, multiply them together just so that we have to factor them. Way easier to factor in this form than it is when you multiply them together, especially when they get large. So that's the concept I'm going to work on. So I'm going to have 8 is, and I'm still going to be using these perfect squares. What's the largest one that goes into 8? Well, 4. What's the largest one that goes into 12? 4. So that's going to be 8, which is 4 times 2, and 12 is 4 times 3. So that means, well, first of all, that's a perfect square and that's a perfect square. But if you remember on the first video, when I have square roots, there's a little 2 there. And because I have 2 4s, I can bring out 1 4. Or you can think about the fact that the square root of 4 is 2. The square root of 4 is 2. So I have 2 2's on the outside. And 2 times 3 is not a perfect square. So it gets left inside. Okay, these 4's got to escape. The 2 got to escape from it. So my answer is 4 square roots of 6. But this is keeping the numbers smaller for you, making it easier to find those perfect squares. So 3, so look at number 23. We got square root of 3 times square root of 12. Well, if I have one by itself, I'm all going to go, wow, does 3 go into 12? It does. So I carry down the 3, and then I've got 12 is 3 times 4. Well, whenever I have 2 of something, I didn't mean to do that. Stop. Okay. Whenever I have 2 of something, I get to bring 1 out. And this is a perfect square. 4 also is a perfect square. So I bring out 1 3 because I have 2 of them out there. And the square root of 4 is 2. So that's 3 times 2, which is 6. Now, again, you might be going, well, 12 times 3 is 36 and the square root of 36 is 6. That's fine. But I'm trying to get you to understand the concept, because there's going to be a time where you can't just multiply these things together. And if you understand, again, stop. If you understand, I don't know what just happened. Where'd it go? Okay. If you understand what it means to factor these things and to be able to bring them out, you're going to be more successful. Okay, so 5 times 20 is 5 times 4. So that's 5 times 5 times 4. There's the 5. There's 20 right there. 2 5s makes it a perfect square. 4 is a perfect square. Bring out 1 5. Bring out the square root of 4, which is 2. So my answer is 10. Again, I'm just trying to help you understand this concept. 4 itself is a perfect square. Square root of 4 is 2, so this is going to be 2 square roots of 3. All right, now this one's different from what we've done already. And this concept that you need to remember is if it's on the outside, it stays on the outside. So 6 and 3 stay on the outside, 2 is carried down, and 18 is 2 times 9. Well, there's a perfect square, there's a perfect square. So this is 6 times 3 times 2 times 3. I went ahead and multiplied that first 6 times 3. But you don't have to. You can put it in there. 18 times 6 is 108. All right. And here, the 2 is on the outside. It stays on the outside. I have a 6 and a 3, but I'm going to break up the 6 to 2 times 3. And then I have 2 3s under here, which makes it a perfect square, which means I can bring it out. So that's 2 times 3 times the square root of 2, or 6 square roots of 2. All right, last one in this. All right, is, and if I didn't say it at the beginning, and if I did, I'm going to say it again. Remember, please don't do these on a calculator that does the work for you. You're only hurting yourself, y'all. You're not learning the concept, and it's going to hit you down the road. So try to learn it now when it's easier, and you can check yourself with the calculator. That's what they're good for. All right, last one on here. Square root of 13 times the square root of 52. Okay? 13 goes into 52 4 times. So 2 13s, when I see 2 of something, it's a perfect square. 4 is a perfect square. So that's going to be 13 times 2, which is 26. All right. That's all of part 2. Thank you so much for watching. Y'all, if you have any questions, you got a neighbor. You also have Delta Math videos that can give you some more explanation. He probably multiplies them out. But anyway, I'm hoping this is helping you keep it short and simple. Thank you for watching. If you have any questions, please don't hesitate to email me or come see me.